Hello, so here's our first video on looking at the different applications of percents, and this is in lieu of class on Tuesday the 13th, so sorry about that, but I had to cancel it at the last minute, so I should be back Thursday, no problem. All right, so when you're looking at applications, remember that it's really important to understand what's going on in the problem. And remember, I do recommend really reading out loud if that's an option wherever you're studying. Figure out what your plan is, actually do the plan, and then look back over your results. And you really need to look and see, do they make sense? Because if you get, for example, a sales price that is larger than your original price, then that wouldn't make sense. So that's going to be a hint to you that you've misplaced some of the information that you were given in the problem. So some specific terms looking at discount and sales tax. So we've got discount is the reduction in the original selling price. Now that's a dollar amount. The sale price would be the original price minus the discount, also a dollar amount. Rate of discount, so that's the percent of the original price to be discounted. That's going to be a percent though. So rate of discount and discount are two different things. Sales tax, tax based on the sales price and actual selling price in dollars, and the rate of sales tax, that's going to be in the percent form. So again, we have two different terms talking about the same basic idea, but one of them, the value is going to be in dollars, and the other one it's going to be as a percent. All right, here are some basic ways that you can look at these. I am going to look at the percent proportion most of the time, and that really kind of can replace these top four that I have written here. But the percent increase and percent decrease, these are really the same. You just need to figure out the amount of that difference, whether it's an increase or a decrease, divide it by where you started, your original amount, and multiply that by 100%, and that'll give you either percent increase or decrease. And whether it's increase or decrease, you should be able to tell by the problem. Your starting point is going to be smaller than your ending point if it's an increase, and vice versa if it's a decrease. Okay, so looking at one of the basic ones that we would have, and again, I said I am going to look at that percent proportion because I think that it can be very helpful to figure out what goes where, because we cannot depend on the is and of hints that we can in the basic percent questions. So if we are looking at sales tax for a county in Wisconsin is 4.5%, compute the amount of tax on a new personal MP3 player that sells for $64. All right, so the price that you pay is going to be what it's based on. That's what your tax is based on. If you spend more, you have a higher tax amount that you have to pay. Now the rate is the 4.5%, and that is the tax rate. And what that means is that what I should get out for my amount is the tax amount. So still talking about the same ideas, how much of the tax it is, but remember this one would be a percent and this one will give us a dollar amount. So if these two, if R and A are talking about the same idea, except one in a percent form and one in a dollars form, then you are good to plug the values in and solve the problem. So 4.5 over 100 is A, our unknown, over 64. And then we will cross multiply and divide to get our answer. Get the calculator out here. All right. So 288 equals 100A. So A then would be $2.88. And then thinking about that, if you are doing this at a 5%, it's less than 5%. So your amount here should be less than 10% of my original price. Remember, we did that quick how do you figure out 10%? So if you have $64, 10% is $6.40. So if we're looking at less than half of that, because we want only 4.5%, yeah, that's going to be in the right ballpark, because this, if we take half of this, it's $3.20. And, that's a little bit bigger than the 288. And that should put it right where it makes sense. Now, if you had gotten something that, for example, was larger than $64 or was maybe like $28.80, which is an easy thing to do if you make a mistake with moving your decimal point, then, this is where you have to think about, does $28.80 of tax make sense if I'm only looking for less than 5% of this? And that would be no. So again, look for those situations where the amount of the price, the amount of sales tax, or whatever it is that you're looking for here, doesn't make sense in the problem. If it doesn't make sense in the problem, and you guys are consumers, so you know what makes sense for these things, then you need to look back at what you put where in your percent proportion and make sure that it was correct. Yeah, because sometimes it's just a little calculator error where you mistype something and it ends up not where it is supposed to be. Okay, so the next one here, we have a shirt labeled at $42. So that's going to be my sales price, my retail price there. John purchased the shirt and paid $44.10. How much was the sales tax? What was the sales tax rate? So there's a couple problems in here. That to find the amount of sales tax, we're going to take what they actually paid and subtract off the price of the shirt. So subtracting off the $42. So $2.10 is the amount of tax. So there's our tax in dollars. Now we want to find also the sales tax rate, and that's where we're going to pull the percent proportion into use here. So we aren't going to know the sales tax rate, but and I'm going to put a little note to myself that the sales tax rate is what I'm looking for here. The amount of the sales tax, though, we do know because we just found that from our subtraction. That was the $2.10. And then base, remember, that's going to be what the tax is based on, which is that original price that you paid for the shirt before tax. So putting everything into our percent proportion. So we don't know R, this is 100. Okay, so A, $2.10, B, $42, and then we will cross multiply and divide. And then we are going to get 5%. All right, and then going back, does 5% make sense for this situation? And yeah, right, 10% of this is $4.20, and so actually that is exactly half of that. So that 5% makes perfect sense as an answer for the sales tax rate. The next one, we are looking at a commission situation. So commissions work in different ways. Most of the ones that we're going to be looking at are going to be percent-based because we're looking at percent applications. And this person gets a 7% commission on any new policies that they make. Meaning that they, based on the amount in dollars that they sell in policies, they get a percentage of that as part of their money. So let's look at our unknowns and our percent proportion. Okay, so 7% is the commission rate. And we want to find out how much he made in commission. So that's good because that matches up with the rate that we have. we want the commission in dollars. And then B is what do you base that commission on? And that's those new policies that Zach sold. And then we'll go through and plug all those values in. So at this point, this really, remember, is going to be the hardest part of this. And then from here on out, this is going to be something that is going to become old hat very quickly, where you're going to be doing that cross multiplication and then division to get your answer. All right, so we get 3,360. Now that should be dollars because we are looking at the amount of commission he earned and not the rate. And let's just double check. All right, his commission was less than 7%. So, was equal to 7%, which is less than 10%. That's where I was going with that. So 10% would have been $4,800. So does 7% being $3,360 make ballpark sense? And yeah, it does, right? It's smaller than 10%, but not a terrible amount smaller, which 7% is not terribly smaller than 10%. That's pretty close. So $3,360 in commission is what Zach earned based on that. Now this next one gets at the kind of problem that tends to trip people up the most, because we end up having to do a subtraction at some point in this problem. So a bathing suit is on sale for $45. If the regular price is $60, what is the discount rate? All right, so for this, we know we don't know the rate, but we want it to be the discount rate. So that's the part we don't pay, which is different from the part that you still do pay. The original price, the $60 bathing suit, that's going to be your base, because everything it gets based off of that regular price. And then the amount here, I need to have that match up with the discount rate being what I don't pay. So there's two ways to look at this. One way is what I'm doing right now, and I'll show you the other in a moment. If you have to figure out the rate of what you don't pay, then here we need to subtract to figure out the dollar amount for what we don't pay. 60 being my original price, 45 being what we actually pay, and then when you subtract, you're going to get $15. So that is going to be the amount that we do not pay. So this is the discount in dollars. Now that R and A are talking about the same idea, I can go ahead and put those pieces of information in here. And what will pop out for R will be the discount rate, the part that we don't pay. So 60R equals 1,500, and R equals 25. And that is going to be, remember, a percent, so 25% discount. Now, the other way that you can look at this problem is by saying, all right, well, if I know that I get, I have a $45 for what I do pay, and $60 was my original suit, I can find the R that matches with what I do pay. So this is, remember, the sale price. In other words, what you do pay. So then make this the rate you actually pay. And essentially what ends up happening is that we have to subtract at some point. So in the one that I did first, we subtract